Good morning, everybody. Today we're going to talk about some organic compounds that are commonly found in foods and smells. So these will be some things that you'll be familiar with by smell or by taste, but you may not be familiar with by name and structure. So we'll just get started right at the beginning. Our first two things that we're going to talk about together are called aldehydes and ketones. The aldehydes and ketones have this carboxyl group attached, which is just a double bonded oxygen on a carbon. That's a carboxyl group. Now, the only difference between these two compounds is an aldehyde has the double bonded oxygen on the end carbon. Right, so I just drew 3 here. That's fine. That'll work, right? So we need 1, 2, 3, 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. So that would be an aldehyde. The double bonded O is on the end carbon. A ketone, the double bonded oxygen is going to be on a carbon that's not on the end. Right? So there you go. Subtle difference, right? Not much difference there. You'd say, oh, why isn't that the same thing? Well, it's again another polarity, right? It makes it polar. We have the oxygen on the end instead of in the middle. This is going to be more polar. It's going to act just a little bit different. Okay. So, again, I didn't want to have to do a bunch of notes and have you write a bunch of stuff down, but aldehydes and ketones dissolve in water. And it all depends on how long the chain length is. That's a common theme, isn't it? That chain length makes a big difference. And they can dissolve in water. Look at our little picture. Look at that. Looks familiar, doesn't it? So the hydrogen of the water is attracted to that double bonded oxygen there. And so it's making it dissolve. Right, and that's a hydrogen bond in there. All right, now aldehydes and ketones, you'll see these things in perfumes and smells and flowers. And some things that you probably know would be like the smell of cherries, right? Sweet. I don't know if you smell this very often. If you we're a little bit cold for this, but a flower known as jasmine, oh, it smells so good. Honeysuckle, another super sweet smelling flower. Now honeysuckles, Japanese honeysuckle is an invasive species in Ohio, so please don't plant any Japanese honeysuckle, right? Especially in southern Ohio, they've been trying to weed those things out for years. They wrap around like a vine and they kill trees. So don't plant any, but they do smell good. Almonds, that smell of almonds, and the smell of strawberries. Oh, those things all smell so good and sweet, right? And that's the aldehyde ketone smell. Okay. Now, how many people like baked bread, right? And the smell of herbs, oh, that smells so good. So aldehydes, pumpkin smell. Oh, there's your pumpkin smell right there. Now, let's look at some of these names. They give these aldehydes really cool little names. These aren't the official IUPAC names, but the names are so descriptive. Now this one right here is called strawberry aldehyde. I wonder what that's in. Right, we have a little benzene ring there, and there's, see that right there? There's our double bonded oxygen. So it's got some other stuff going on there, right? But it is an aldehyde. Oh, cinnamon aldehyde. Cinnamon, right? Cinnamon aldehyde right there. And then vanillin is the stuff that is in the smell of vanilla. So those things are all really sweet smells. And I think you kind of get the gist of what it is. So cinnamon, vanilla, and those kind of things, they all kind of evaporate out when you cook and you can smell them. They smell so good. All right. So naming aldehydes. So we're going to name these separately. So the aldehyde what we're going to do is we're going to change the last part, and we're going to end it with an AL. Okay, instead of like being methane, it'll be methanol. All right, so let's see what we got here. All right, I'm going to go to a nice gray color. Here's our carbon, right in the middle, right? So we have one carbon. So that's going to be meth. And then instead of writing methane, because we have the double bonded oxygen, we're going to write methyl. Oops. Sorry. Meth and al. Right? So instead of being methane, you'd add that AL ending. All right. Here's one that has a chloro group on it, so I'm going to do that one. All right, now we have 1, 2, 3, 4, 5 carbons there. All right, and we're going to start. This is going to be number 1 because it's right there by the double bonded oxygen. 2, 3, 4, and 5. So 5 is pent. And they're all single bonds, so that's pent AN. If there were a double bond in there, right, if that was a double bond, it'd be an EN. But it's not, it's a single bond. So let's get that out of there, Mr. Arnold. Okay, and then because it's an aldehyde, we're going to end it with that AL ending. All right, that's nice, huh? Now, we have this Cl attached. Remember, that was a chloro. So it's on the second. Oops, I forgot to put my thing on here because the double bonded oxygen's on the one end. Well, it'd always be on the one end, right? Because it's an aldehyde. I'm gonna put it there anyway. So we're gonna have 2 chloro, 1 pentanol. Okay, I can put another dash here too. That'll make it look cooler. All right, how's that look? All right, be careful for these groups. I'm not gonna do any more of these. I get carried away. These are the carbons, right? There's 2 carbons there. I just went and found different pictures off of, I think it was on Google Image, right? So look at this chain right there. And then we also have a methyl group there. Don't forget the methyl group. All right, so start. Okay. Right, you're going to start your 1s here. And then there's your meth. Okay, I'll leave those 4 to you. Okay, now ketones, similar type thing. Now, remember, this time it's going to end in, it's going to end in 1. So it's going to end in -one, right? And so we're going to do the same exact thing, except instead of writing AL at the end, we're going to write ONE. Oops, where are they? Here they are. Okay, so the difference again, the double bonded oxygen is not on one of the end carbons. It's not on carbon number 1, is it? Right? And I will do the last one. That looks fun. All right, so I'm going to start with this 1, 2, 3, 4, 5. I should have put some double bonds in these, but I didn't. So we have pent. Right? Pent for 5 carbons. We have AN, and it would be pentane. Don't write that down yet. It'd be pentane if there was no oxygen on there, but there's an oxygen on there. So we're not going to have that. Instead, we're going to have pent, O-N-E. Right? And then where's that at? It's on number 2. Okay, try to name these 2 over here. Remember, start with number 1 over here. This one doesn't matter. Okay? Not too bad, huh? So there's 6 to name. See, I saved you some. I get carried away. You know that. I just like to draw them. All right, now, so what we have here are, we're going to draw some pictures. And again, I did the old cool little thing about it because we like to know what they are. And a lot of these common names you'll know. Formaldehyde. That's embalming fluid, right? And they use it, they make plastic too out of that. They don't make it, turns chains, it causes polymerization. That means it makes these small little chains stick together. So formaldehyde, though, is used to embalm things. We used to keep like animals in the biology lab in formaldehyde many, many years ago. They don't do that much anymore. Let's go blue. Okay, so aldehyde. R, double bonded oxygen on the end. Okay, that's all we're doing. So I'm gonna leave that first one for you because it's an easy one. Nah, they're both easy. I'll do the first one here. So meth means 1. AN means single bonds. It can only have single bonds in there because there's only 1 carbon, right? So meth, and then we're gonna put double bonded oxygen on this side, and then we're just gonna fill in these small ones. I like to draw my H's on there. There you go. Now, this is a byproduct of methanol digestion. I bet you've heard that sometimes people drink moonshine and they go blind, right? That's because if you distill or separate the two alcohols wrong, you can end up with a lot of methanol in a container. Methanol and ethanol have different evaporation rates. This is distilling. So we would do this in class if we were in class. But we have this little mechanism that looks like this, right? And what it is called a distillation flask. And so you'd have your mixture of, say, methanol, ethanol, and water. And that's what we would make, like if you were making alcohol, the yeast was fermenting the sugars that would make ethanol. If the fibers, the plant fibers, also go through fermentation, they form methanol, which is poisonous. Ethanol is the alcohol people drink. Okay, so they evaporate at different rates. I don't know the exact rates right here. Maybe I do have them. I have them somewhere. I could look it up. I'm not going to though. All right. So what happens is methanol is the smallest molecule, right? So it evaporates first. So I think it's 64 degrees. Don't quote me on that. That's Celsius. So the first thing starts to evaporate. I'm going to say 64 degrees just for, because I don't feel like looking up right now. And then the methanol starts to boil. Right? And as it boils, the other things aren't boiling yet, just the methanol in there is boiling, and it evaporates. And then what we have is this condensing tube, and we run cold water through this tube. Now, you say, well, doesn't that mix back in? No, because it's a tube around a tube, and it flows around there and cools it, and then those vapors condense back into liquid, and that's what they collect, and that's how they start to distill things, right? A still, like they see on the moonshiner shows, right? There we go. And so the first thing that distills is the methanol. After all the methanol is gone, remember the temperature stays the same while whatever's boiling boils. So the temperature stays at 64 while that methanol is boiling. The moment all the methanol is boiled away, the temperature rises. I think it's 78 degrees Celsius. and then the ethanol, and that's what they're trying to get, the alcohol they're trying to distill out is. And so there's a definite temperature change there when that happens. And then when all the ethanol is gone, the temperature is going to shoot up to 100 degrees Celsius, and that's water boiling. And so they use the boiling point to separate the liquids. Kind of distillation. All right? And so that's how you separate. Well, people get sick from this, and it happens all the time. You see this on the news, is because the very first part, that first container, contains all of the methanol that was in the whole batch. And so if they're doing these huge mega batches, that first container has has all the methanol in it, which is poisonous. All right, let's do fun here. Methanol. All right, now going through digestion. First thing that's going to happen is your body is going to remove a hydrogen because it's the easiest thing to get rid of, right? It can't remove this hydrogen. Oops, not that one. It can't remove that hydrogen because that hydrogen is attached to the oxygen, which is holding on. It has the highest electronegativity, so it's holding that hydrogen very tight, right? So any of the other three are fair game, though. And so one of these hydrogens gets removed. Well, you know carbon, it can't be just with 3 bonds. So what happens? It forms a double bond. And it has to form a double bond with oxygen because oxygen is the most electronegative, right? And so it wants to form that double bond there. Well, once the oxygen forms with the carbon, that kicks out our last hydrogen, this one right here, and voila, we have formaldehyde. And so one of the byproducts of methanol digestion in your body is the formation of formaldehyde, which is also embalming fluid. All right, so I'll let you draw those other things there too. I just thought that'd be a little fun fact for you. I can tell already I'm going to have to break this into 2 lessons. I got a little wordy. Okay, so drawing ketones. So drawing ketones, the double bond oxygen is not going to be on the end. Now there's 2 examples I have here, and these 2 examples don't have numbers in front of them. And the reason they don't is because really there's only one option of each, right? Because we know, and I'll show you I'll put it on there, but I'll show you in this one. So this has bute, so 4 carbons, 1, 2, 3, 4, right? And it's AN, so single bond, and then that ONE means there's a double bond on one of those middle carbons. It doesn't matter which middle carbon we pick, because whatever one we pick, that turns this side into number 1, right? Let me draw my hydrogens on there first, right? There they are. So that makes this, let's change colors. That makes this carbon number 1, 2, 3, and 4. Let me draw the rest of my hydrogens on there. That was blue, right? So that one already has 4. There we go, right? And so that would be 2 out here. Now, if we do it the other way, right, we put it here. Oops, we got too much H's on that one, don't we? And we drew it out here like that, right? What happens at that same time is that makes this carbon number 1 and this carbon number 2. And so we're back to the same compound. So that's why they don't have those numbers on there. Those numbers are optional if there's only one possibility. Okay. All right, I'm gonna have to stop after this little teeny section here. These are the amines. Now, I don't have this as the same as other groups because it's a little different. But these are derivatives of ammonia. Ammonia is this, right? And all it means is it has a nitrogen involved. So the amines will include things that have a nitrogen in it instead of attached on. So there's ammonia. And look at this right here. This has a carbon groups here. This is going to be our hydrocarbon, and it has two H's. This one has a hydrocarbon, and then one H. And this one has all three. So there's different variations of that. And you've heard of amino acids and things like that. And if we have time this year, which I don't know if we will because we're running out of time, we'll talk about amino acids and draw a few of those. But that's the amine group. Okay. So I'm going to call that lesson 1 and finish drawing those other pictures. It won't be that hard, right? Fill in any notes. We didn't have that many notes on there. I do have another section about that ethanol. I could set up a video about that if you would like, as an option to look at. But if you do want that, just let me know, and I can put that up on YouTube also. But just finish that up as lesson 1, and then we're almost to the end. We have the acids, and then we have the esters. And then we'll have a little review, and that should take us through this whole chapter. Okay, so we got some pretty cool stuff coming up. They're kind of fun, but I don't want to go over my limit. So